Now let us go for the next question. So in this question, Pn of r is given. So it is same as Pn of x, but in our question bank it is said as Pn of r. So I will use the same notation throughout. So it denotes the same vector space, that is space of polynomials with real coefficients having degree less equal n along with 0 polynomial. So again one linear transformation is given. So in this case they have clearly mentioned that d is from Pn of r to what? Pn minus 1 of r. As we know, once we take the derivative, degree is reduced by 1, right? So therefore this n minus 1 is here, and it is defined as d of f is equal to df of 1 dx, means we are going to take the derivative of f, and another one linear transformation is given, that is t from Pn of r to now Pn plus 1 of r. Why Pn plus 1? Because over here see how t is defined. So if we operate t on certain polynomial, it is going to be multiplied by what? X. Means if I want to give one example, if you are having x cube plus 4x square plus 3x plus 1, and if I operate t on it, so what will be t of f? It will be x raised to 4 plus 4x cube plus 3x square plus what? X. So in this way your t is defined. Now over here, first of all we have to find kernel of a. Remember what is a? A is this, okay? So a is another linear transformation, and it is from what? Pn of r to Pn of r, and over here they have asked us to find kernel of a and this dimension of quotient space, that is Pn of r mod kernel of a. So let us go then, okay? So if you want, I will write down the definition of kernel again over here. Our kernel of t, if t is from v to w, is nothing but what? Somewhat like this, right? So I will say we know actually we know kernel of this a is defined as which notation? Small f belonging to what? Pn of r. Just see what is the domain of a, Pn of r now, such that a of f is equal to 0 of Pn of r. I will write as bold 0. So which is further equal to set of all f belonging to Pn of r, such that now what is a? A is dt minus td of f, which is equal to our 0 polynomial, which is further equal to set of all f belonging to Pn of r, such that put that f inside, so dt of f minus td of f is equal to this 0 bar, which is further equal to set of all f belonging to Pn of r, such that now t of f is actually nothing but what? See how t is defined. Just now I have explained. It is simply what? Multiplying that f by x. So it will be d of xf minus t of, and what we will have here, d of f is nothing but what? Df upon dx, which is further equal to this 0, which is equal to set of all f belonging to Pn of R such that, now simply take the derivative. Now note, f is a polynomial in x, and this x is also a polynomial of degree 1. So d stands for the derivative, so we are supposed to use the product rule. So x as it is, derivative of f is df upon dx, plus f as it is, now derivative of small x is 1, minus, now t means multiplying by x, so we will multiply this df upon dx by x, which is equal to 0 bar, which is further equal to set of all f belonging to Pn of R such that, so you can easily see this and this will get cancelled out, right? Right. So what is left out? F is equal to 0. So this is nothing but what? So it is collection of all those polynomials in Pn of R such that that polynomial is itself 0. So it is singleton what? 0. So therefore our kernel of A is equal to what? Singleton 0, and therefore what is dimension? Okay. Therefore dimension of kernel of A is equal to what? 0. Okay. What is the basis set? You should know it. Okay. Basis set is the empty set, and empty set contains no vectors, right? 0 vectors. Okay. So we have found out kernel of A. Now next thing, they have asked us the dimension of Pn of R mod kernel of A. So therefore dimension of Pn of R mod kernel of A will be equal to what? Okay, we know it. Dimension of V mod W is what? Dimension of P of R, that is dimension of V, minus dimension of W, that is dimension of kernel of A. But what is dimension of Pn of R? It is n plus 1 minus dimension of kernel of A is 0, so which is equal to what? N plus 1. Okay, so that's all for this example.